Hello everyone. The topic for this lesson is graphing equations with Desmos. Now, I'm sure many of you have used Desmos before. If you haven't, just Google Desmos, and it's the first thing that comes up, Desmos. And then you press the big red button, and it takes you to this graphing calculator screen. And I think some students that I work with have tended to have like a negative impression of Desmos, perhaps because maybe a past teacher forced them to use it a lot. But I really cannot understate the usefulness and power of Desmos as a tool. Now, first off, Desmos we really think of as a graphing calculator, right? But also know that it can do like normal calculations as well, as in it can evaluate expressions. So for example, if I type in 3 plus 2, and there's a little box that pops up here that says it equals 5. Or you can do weirder things as well. So if I type in SQRT for square root, then what is the square root of 10? It's that weird number. So again, the value of that expression pops up. You can do all kinds of things. Sine of 30, for example. And by the way, know that there's various settings in this wrench icon over here. So if you press that, for example, you can switch between radians and degrees. So currently we're in radians, and so sine 30 gives that value. You can switch to degrees, and it gives a different value. So again, you can calculate values of expressions. Now for graphing, you've probably entered equations like, I don't know, y equals x squared minus 3. And that makes a graph, of course, a curve. But in our previous lessons, if you think about it, we have now learned a bunch of different types of equations. And it turns out that you can actually graph those different types of equations in Desmos. So let's see how we can do that. So let's talk about different types of equations. First up, we've got Cartesian or rectangular equations. And that's that common type of equation that you've probably worked with the most in your previous work, right? Those equations where we've got just one dependent variable, often called y, and then just one independent variable, often called x, right? And those variables can show up more than once in the equation. And then another type of equation is parametric equations. And parametric equations are sets of multiple equations or sets of multiple dependent variables given in terms of independent variables. So in our lessons, we've worked with sets of parametric equations where we've got two equations and we've got two dependent variables, x and y, given in terms of one independent variable, the parameter, right, t. And then another type of equation is polar equations, where the variables are r and theta, and r represents the radial distance, right, the distance of each point from the center, and then theta represents the angle relative to 0 degrees. And now it turns out that all of these can actually be graphed in Desmos. So first, let's talk about parametric equations. And again, the parametric equations we've been working with have all involved a set of two equations, one for x and one for y, given in terms of t, right? And if you think about it, when we worked with these and made tables and graphed it by hand and such, we had like t values that we plugged in here, and that gave us, for every t value, that gave us a single x value and a y value. And so for every t value, that gave us a point, right? Like an xy coordinate, parentheses, something, comma, something. So it turns out in Desmos, they take like this sort of coordinate point approach where this function, is the function that gives the x value, right? So we type it in here on the left side, right? Parentheses t squared minus 4, comma, And then this expression gives us the y value of each point, right? So we write it like here, like a y value, and so 3t, and then close parentheses. So again, it's just these same two equations or expressions written as a coordinate point. And let's see how that actually looks in Desmos. So here's Desmos. And again, you literally type in parentheses and then the x part, so t squared minus 4. That's the formula that gives the x values, right? Comma, and then the y part, 3t, close parentheses. And so you can see we have some weird curve there. And so let's talk about what Desmos does with the parameters. So when I typed in the equations or formulas here, you see that something popped up down here that says 0 is less than or equal to t is less than or equal to 1. So when working with parametric equations in Desmos, you actually have to specify which t values you want the thing to graph. So right now it's graphing t equals 0 to t equals 1. And you know, 0 to 1, that's not a very big interval, right? And that's why our graph is just this little line here. And now in general, we tend to start the parameter at 0, but we tend to graph a lot more t values than just going up to 1, right? Like maybe we take this, so you can click on it and give a new number. Let's say we want to graph t values from 0 to 10. And now the graph extends farther than it was before. So that's parametric equations in Desmos. But one more thing, for any type of equation graphed in Desmos, know that you can adjust the window of the calculator, right? So you can, for example, scroll with your mouse and zoom in or zoom out. You can also adjust it very precisely by going to the settings button again, you know, the wrench, and you can say exactly which x and y values to show, like what the maximum range for y values and x values is shown. Also, if you're using a touch screen, you can pinch or touch the x-axis or the y-axis and scale only horizontally or only vertically. So you can scale them separately, like here's me scaling only vertically, or you can scale only horizontally. And so you can use these tools to adjust how much or what part of the 2D space the calculator shows. And in that way, you can get a good view on the curve you're trying to graph. Okay, next, what about polar equations? So polar equations, you can actually literally type those in as you would, write them by hand. So R equals, and then an example might be 4 sine, and then let's put 2, and then theta. You can literally type in theta for theta, and that gives you theta in the equation editor. And then let's close parentheses, and you see that we have a cool graph here. And like with parametric equations, Desmos wants to know which range for theta to graph. And like with parametric equations and t, for polar equations, Desmos wants to be told the range of theta values that it should graph. So by default, we have 0 to 360. So it's graphing all the r values for the angles from 0 to 360 for this graph. And of course, you can change the starting value or the ending value. Now, I have this in degrees right now, but by default, I believe it starts with radians. And now if you look, the range for the theta values has changed. It was 0 to 360, but now it's 0 to 2 pi, which makes sense because 2 pi is the radian equivalent of 360, right? And by the way, in Desmos, you can directly type in pi. So let's say we wanted to go further than 2 pi. you can take this and you can say like, okay, 4, and then type in literally pi for pi, 4 pi, and boom, that changes the range. Although for this particular equation, that doesn't change the graph because after theta gets to 2 pi, it starts repeating itself again. But know that there are cases where if you change these values, then you will see more or less of the graph. So for example, if we change this 4 pi to 1 pi, then we only see half of what we saw earlier. And if we go back to 2 pi, and then boom, we see all 4 petals, if you will. So that's polar equations with Desmos. Oh, by the way, so the grid here, the squares and the lines and such, they are rectangular, right? They're the normal type of coordinate grid that we're used to. But if you go again to the settings, you can actually switch between a rectangular grid and a circular grid, which might be more suited to polar equations, right? So it says this circle here is radius 4, and it kind of makes sense that our graph is just touching this radius 4 circle at the tips of the petals. So that's polar equations with Desmos. Now let's talk about Cartesian or rectangular equations. So, the common type of equation like this. And so, you'd think this is the easy case, right? There's nothing much to talk about. But a couple things. So first of all, remember that we can think of the same equation, y equals x squared minus 3, using something called function notation. So we could take this and write it instead as f of x equals x squared minus 3. And, it's basically the same thing. And know that Desmos, you can work with this function notation as well. So again, you can literally type in an equation using function notation like f of x equals x squared minus 3. And I think some students tend to struggle with function notation, but actually this usage in Desmos is a perfect illustration of why function notation is powerful. Just to explain a little bit, y is a variable that gives a position on the graph, right? But f is the name of a function. So we're naming this function with this name f, and that actually allows us to do a whole bunch of different things using that name to refer to the function. So for example, in a different line, now that we've defined the function f, you can type, okay, what is f of, let's say, 50? And now Desmos knows, okay, we're talking about this function that we typed in before, and f of 50 means plug 50 into the function, and okay, we get a value of 2,497. So that's just a brief introduction to function notation in Desmos. Now, more about Cartesian equations, though. So let's talk about explicit functions or equations and implicit functions or equations. So explicit functions or equations are the ones we've been talking about. So like y equals x squared minus 3. And this explicit means that one of the variables, the dependent variable, is alone on one side. That's the only place that variable shows up. And then the other side is some expression involving the independent variables. And we say this kind of equation explicitly defines the dependent variable as an explicit function of the other variables. However, if you think back to some of your previous work, you've actually seen a similar type of equation, but that does more complicated stuff with it. So if you think, you should have seen equations that involve those variables all over the place in the equation. So here is an implicit equation involving those same variables x and y, but now notice that x and y are all over the place in the equation. So we got some x's here. we got some y's here. And then one side of the equation is a constant, although it doesn't have to be that way. In general, you can have all kinds of expressions on both sides. But again, notice that with the implicit case, y is not by itself. The equation has not been solved for y, and often it's difficult to solve the equation for y. And so with this implicit case, there's a lot more you can do. It's more general than the simple case, the explicit case we have on the left. And another super powerful thing about Desmos is you can even graph implicit equations. And typically with older graphing calculators, you can't graph implicit equations, right? So here's Desmos again. And with implicit equations, you can literally type in the equation as is. So we've got x squared plus 4x plus 3y squared minus 6y equals, and then the right side was just 24. And so there's the graph of that equation. And notice that this is a graph that could not be easily defined by an explicit equation. And the reason you know is for some x values, there's more than one y value, right? So more than one output value, as in this thing fails the vertical line test. And that tells you you could not do that with an explicit equation. Again, you could not easily create this graph with one of those common y equals equations. Another useful feature of Desmos is it kind of highlights key points about certain equations. So if you click on the row for an equation, then it bolds that corresponding graph and it highlights some dots on there on the curve. And those dots are some key points like this right here is the y-intercept, 0, negative 3.2, and you can click on it to keep it there. Unclick. Or the x-intercepts, right, the zeros, so that weird number, comma 0, this weird number, comma 0. It even does maximums and minimums, so high points and low points. So like the vertex of this parabola is 2, negative 4. So Desmos just goes ahead and calculates those for you, very useful. Or let's say you have a system of equations, as in you're looking at more than one equation or more than one curve at once. So let's say you're looking at a system involving the original equation, the parabola, notice how it gets bolded, and another equation, this line here. And let's zoom out a little bit here and move. So if you click on either of these equations, Desmos highlights their intersections, right? The intersections of the two graphs. And again, you can click on them. So here's one intersection. There's another. Again, very useful, especially because if you remember how systems of equations work, each of these intersections represents a solution to the system, as in each pair of x and y values is a pair where if you plug in x and y into each equation, that pair makes each equation true. So again, those are some pretty significant points when we're talking about this system. So that's it for all the conceptual stuff in this lesson. But with my students, I'm going to be asking them to take screenshots or snips of the things that they graph in Desmos. So let me show you how to do that on a Windows computer. So let's say we want to copy part of this screen here to show the graphs that we've got. If you go to the Start menu, you can look for what's called the snipping tool. So you can type in snipping tool, and this app will come up. And what this does is it lets you copy part of the screen. So if you press New and then drag, boom, that copies that part of the image. Don't forget you can adjust the view of Desmos so that you can get like a good view of what you're looking at. So maybe I zoom out and then I take a snip like so. Could take a smaller snip as well if you want. So that is it for this lesson. As always, good luck. Contact me with any questions or feedback.